This is a topic 8, lesson 1 example. This is example number 1. I think I might have already recorded this somewhere else because it looks familiar, but here we go. The question from the page before was the scale drawing of the kitchen, and the scale factor is every 1.5 feet of the actual kitchen is shown by 1 inch in the drawing. So we're going to keep that scale factor. So 1.5 feet in real life is the same as 1 inch on the drawing. And we're going to change that relationship a little bit to show how many feet wide it would actually be in real life if you measured something and you got 2.5 inches. So I'm going to redraw this down here so that it looks a little bit more like what we used to do in class, 1.5 feet over 1 inch. And we're going to write a fraction that it's equivalent to, where we're looking for W feet if what we've measured is 2.5 inches. Remember what I talked about in one of those other videos, when you have the equal sign here, if you have inches in the denominator in the first fraction, then you need to have inches in the denominator in the second fraction. This is different than when you're doing your multiplication and then you want their positions to be flip-flopped. So for this one, we have to think, all right, well, what would we need to multiply 1 by to get 2.5? And the answer is we would multiply it by 2.5. I'll put an asterisk there to mean multiply. So we're going to do the exact same thing here. We're going to multiply this by 2.5. And 1.5 times 2.5 is 3.75. So that means the width of the kitchen in that one particular spot is 3.75 feet. I know that these boxes bug us in the Pearson. So if I were to sort of fill it out the way they're asking us to fill it out, this looks exactly like what I did down in the lower left. You're just showing that in order to get, that we're multiplying everything by 2.5. 1 times 2.5 is 2.5. 1.5 times 2.5. No, that's not right. Yeah, I still don't like these. Blah, blah, hate them. Anyway, so don't worry about how they're setting it up here. It's just too confusing. Do it the way that we learned it in class, and then you won't have to remember something new. I'm going to bring up a example 3. I already did example 3 for sure because I saw it on the playlist, but I'm going to do an additional example 3 that's a little different. So, yeah, I'm glad you brought this to my attention because this is one I think some people were struggling on. Here's what's weird about this, right? So I don't have I can't write on this, so I'm just going to use my mouse. So the scale is 1 inch is equal to 3 feet, but we're asking about area here. And so even though the scale is 1 inch is equal to 3 feet, when you look at it like it's an area model, if 1 inch is really 3 feet, then for area, a 1 by 1 square would be a 3 by 3 in real life, and 3 by 3 in real life is 9 feet. So the scale for just the length of it really is 1 inch is 3 feet, but the scale for the area of it, 1 inch square, is 9 inches square. So if you were getting that question wrong, this is why. So let's try this together and see what happens. Okay. So even though the scale is 1 inch to 3 feet, the scale we're going to use for the area is 1 inch square is equal to 9 feet square. So to write and solve a proportion for the area of the actual playground, normally to find the area of just the drawing, you would do 6 inches times 4 inches, which would be 24 square inches in there. But remember, each one of those 24 square inches is 3 by 3. or 9. So look at what they do here. So they're using this scale factor, 9 square feet over 1 square inch. The green A is the area we're trying to figure out what it is. The area of the drawing itself is 6 times 4, which is 24. And now, if I was able to use a pen here, I would say, okay, we need to figure out what to multiply the 9 by to get A. So what would you multiply the 1 by to get 24? The answer is you would multiply it by 24. And 9 times 24 is 216. So in real life, the area of this playground is 216 square feet. So you can't just do 6 times 4 is 24 and multiply that by 3. You have to multiply it by 9 because that's how many square feet you would find in that area that is 3 feet by 3 feet. Okay, confusing, isn't it? Hopefully that helps.